But we have more people coming in. Great. Okay. So because of our time, we have about an hour and a few minutes to spend. So I will start. Share my screen. Yeah. Please let me know if you can see the screen. You can do a thumbs up or, thank you. Thank you very much. Right. Okay. A minute and we'll soon begin. Okay, good evening, everyone, and welcome to the IB Nigeria chapter study group session for today. As we can see, our topic today is data modeling as a business analysis technique. And I'm Adonluwa Shobowale, you can call me Adam. And today we are looking at data modeling as a business analysis technique. So our goal today is not to turn everyone into a database designer, it's just for us to understand data modeling, grab the concept of it and how it is used as a business analysis technique and how it can be used to clarify business languages and expose business rules and improve requirements before a solution is built. Okay, so just before, thankfully, we're not too many at the moment, so I'm going to try to make this. I know that it's in the evening, some of us are already getting tired, so I'm going to try my best to make this as interactive as possible and easy to understand as well as possible. I know a couple of us have different levels of experience. Some people are just starting their journey as business analysts. Some people are, well experienced, and I'll just make sure that this is as easy to understand as possible for everyone. Okay. So before we go into our agenda for today, can I have everyone please just let me know? You can put it in the chat so that we don't have too many marks on. You can put it in the chat where you're dialing in from and what industry you work in or what type of organization you work in. If you can just put it in the chat, where you're dialing in from, what type of industry you work in. Hmm. Are we getting any messages in the chat? I've just realized that I'm not seeing the messages. Yes, okay, great. Can see. Thank you. Thank you very much. Thank you, everyone. Civil Service, Moradi here. Thank you. Tubosun, Lagos Oil and Gas. Oh, great. Lagos, Nigeria, healthcare. Oh, perfect. I'm going to be referencing healthcare a lot, so maybe you give us more insights, Adedeji. Lagos, Nigeria. Hi, Lola. Good evening. Transportation and logistics. Thank you all. Thank you, Lua Sheon, business consulting, Lagos, Nigeria. Amazing. Great, great, great. Okay. Right. Okay. I myself work in education. I'm dialing in from London. I work in education and publishing. So yeah, let's get into it. So today I'll be taking us through this agenda. This is practically our journey for today. We're going to start with the basics. As I said, we'll understand what a model is, what data is, and why businesses need data to run. And then we'll build towards the BA technique, which is data modeling, and go into more details as much as we can within the time that we have, and how to identify entities, attributes, and basically the anatomy of the business or of a data model. Right. And for today, our learning objective would cuts across these areas. Ideally, by the end of today's session, I want us to be able to explain what data modeling is, describe the role of data in business systems. I want us to be able to identify the major components of a data model and differentiate between the different types of a data model. And hopefully, you should also begin to begin reading simple data models confidently. Right. Okay. So we've all put in the chat, the different industries we work in. And I think it was Adedeji who works in the healthcare system. Business systems run on data. We know this. A banking system would store data about customers, about accounts. An HR system will store data about employees, roles, payroll, development, skills and development, learning and development. A healthcare system will have patient records, appointments, and things of that nature. There are certain things that different businesses are important to different businesses, and there are things that the businesses need information about, right? So I'd like to ask us, and please feel free to either do what you're comfortable with, type in the chat, what do we think a model is? Just a simple, this is not anything technical. Just a simple question, what is a model? What do you think a model is? You can drop a message in the chat. And it's very okay if we're not sure the context, but I'd like somebody to try what you think a model is. And you can also be within the context of what we're talking about, because I know some of us are, fully experienced. A model is a template or an example of something. Thank you. All right, okay, that's a good simple explanation of, it can be right. Okay, anybody else wants to give it a try? What a model is? Okay, right. So models can be, blueprints. They can be things that help us, or prototypes that help us understand the things that we're dealing with, right? Think of maps, blueprints. It helps to simplify reality. It helps us simplify, yeah, just as I said, simplify complexity. It helps us to communicate faster. It helps us to test ideas safely. It helps us to, design before building. Let me see, okay, no, it's still more. Okay, great. So we have clarity about what a model is. It's a representation of something that needs to be understood and or communicated, right? It's a simplified representation of reality, and it helps people to understand, to see the important parts. It helps them to analyze, communicate, and design before, a solution is delivered or before building, right? So that's the understand. Now I believe we have a clear understanding of what a model is. Moving on, what business data do you work with daily? So at this point, I'm calling on everyone. We've all dropped in the comment industries. What type of data do we work with on a daily basis? In the healthcare, consulting, oil and gas. If you put in the comments in civil service, what types of data do we work with on a daily basis? Hmm. Anyone? Thank you, Lyle. Customer details. Thank you. That's really good. Let me see what industry. Yeah. Thank you, Lyle. Customer details. That's an example. It could be anything, depending on the industry you work with. It could be patient name in the hospital, healthcare, we could have patient name, prescription number. If it is the banking industry, we could have account number, customer details. Like Laya said, okay, we have a new message, traffic flow across Lagos, client details. Thank you very much. Exactly. So I want us to, I want it to be simplified so we can understand the basis of it, right? So every organization handles facts that describe people, events, decisions, transactions. You have names, you have dates, you have transactions, balances, employee ID, different types of data. And in the definition of data, it's a raw fact. It's raw facts, figures, observations of things that a business can store, process, and use. And it becomes useful when it is structured and analyzed and connected to mean something useful, right? Okay. So I'll move on to data modeling. Can anybody take a stab now? We've understood what data is, right? We understand clearly what a model is. What is data modeling? Right. Data modeling is the process of creating a visual representation of business information, its relationships, its rules, and its structure, right? A data model helps the business to identify business data. It's that lower level of data. I know that some of us as business analysts, one of the, most popular things that we do is process mapping. And sometimes we don't realize that we need to create data models as well. We need to understand it could be in different formats, it could be in different types of data modeling techniques, it could be through an entity relationship diagram, it could be in the situation where you need to have a shared understanding of the data moving from one system to another, and you need a data dictionary. It could be trying to understand the flow of data from the enterprise level down to the lower levels of the business, and you need to do a data flow diagram. There are different visual representations of the business information, of the things that the business cares about. And within an IT project, we could have one or more data models. As I've said, there are different types, right? And it's usually used to represent the what data the business needs to record. As we've put some of those examples in the chat, the things that the business cares about, right? You need to identify that business data. What does the business need to record, right? And we need to structure the data. We need to define the relationships between the data. Lola talked about traffic flow across Lagos and client details. In that industry, there must be a relationship between the client details and maybe the traffic flow, in that industry. We talked about, Adeji mentioned healthcare. There will be relationships between patients and appointments, things of that nature. Just think about it in that nature. The what that the business cares about. So what data the business needs to record. The data model here will be a complete, concise, and unambiguous statement of that information requirement of the business. There's also the how, apart from what the data and the business needs, there's how the data also needs to be structured and organized so that it can be retrieved and analyzed, right? Typically, the business analyst deals mainly with the what. That is the responsibility always of the business analyst, while the second how could be the responsibility of like a database designer who would, talk about how exactly it will be structured. So we just talked about a data model or data modeling. Data model itself is the same. It's a visual or logical representation of the business data, showing the relationships held within the data. On screen here, you can see a simple relationship. This is just a very simple diagram showing customer, customer to order, customer places many orders, the products. It just shows that relationship. We have a definition here. Data model represents business data and the relationships between that data. We use models to analyze information and communicate requirements. While we're working as business analysts, our job is not only to, produce the functional requirements, we also have data requirements, right? And just as sometimes doing a process map can help you ensure that you've looked at your requirements end to end and it's complete. It's the same way like a data model would help you ensure that there are no holes, and you've looked at all the data requirements required for whatever is being implemented or what you're building. So this represents the business data and the relationships between the business data, right? Okay. I hope we're all still here. Please give a thumbs up if you're still here. Or let me see. Can I see everyone? Yes, thank you. Thank you. Thank you very much. I need to be sure I'm not just speaking to myself and other people are here, right? So moving on, we've defined data, we've defined modeling, we've defined what a data model is. And now we're going into, more details. But it's important to note here that a model is not just a technical drawing. It needs to capture the business vocabulary. It brings out those business rules that could have been missed and the business constraints as well. Okay, why businesses need data modeling? I've mentioned some of this as I've been talking. Businesses need data modeling for several reasons. And of course, this is not everything, but we'll just touch on communication. It'll help stakeholders to have a shared understanding of what the data is. Let me give a simple example. In a business, there could be several departments, several units, and a unit might have a word, or maybe they use customers for people who have already been on board or been onboarded, while other people in another team use customers for people who are potential clients and have not been onboarded yet. In that situation, it's the same word, but they have two different understandings. They don't have an agreement. So sometimes when you have a data model, it helps to elicit completely what the shared understanding and what core terms mean within the organizations, and it gets the stakeholders to agree on what those core term means. It also helps with the data quality. The data quality must be, complete and valid. It helps with integration. It helps with requirements. Like we said earlier, hidden rules become more explicit. It helps with reporting as well. I even believe it helps, for you to be able to implement data governance policies in an organization, you need to first know what the data is. And when you're drawing a data model, you would need to first understand what the data is before you can come up with a data model, understand what those core things are that are important to the business and what the relationships between them are as well. Great. Okay. So I'll move on to the next slide. We can also deduce from this there would be hazards where proper modeling is not done, within a project. Systems become inconsistent. We wouldn't be able to do the reporting. The reporting will become unreliable. The requirements would be, incomplete. There'll be a lack of consistency. But having this modeled would help the business. And what makes a good model? It needs to be clear, it needs to be simple, it needs to be accurate, it needs to be consistent. Yeah, we just said lack of consistency. Yeah. And it needs to be validated with stakeholders. Very, very important. As business analysts, and I think I say this a lot, people assume, a lot of, especially new business analysts, have that fear that you're supposed to know everything or you're supposed to be the SME in your project. Yes, the business analyst can double as, the expert in a certain industry, but part of your job is ensuring that you have that stakeholder alignment. When you get into a new industry or you're consulting on a new project in an industry you haven't worked on before, that domain knowledge, the knowledge on what that business needs, you need to ensure that is validated with the stakeholders. You have no business as a business analyst, no pun intended, you have no business assuming or making assumptions that this is what the data is, this is what the data means. Everything you do at every point must be validated with stakeholders, right? And yes, it must be business friendly, it must be scalable, it must be easy to maintain. Now, we're going to go into the details of the anatomy of a useful model. So these are the core components of a useful model, right? Okay. Just getting myself a glass of water. Okay, so this is going to be our working vocabulary for the rest of the session. We have entities, we have attributes, relationships, cardinality, optionality, business rules. Yeah, cardinality, optionality, business rules. And as we can see, an entity is a business thing worth remembering. We had Lyle tell us customer in the chat. That business has a customer. A hospital, in Adedeji's case, would have a patient, for example. That's an entity, right? Now we have attributes. Attributes is a fact recorded about the entity. So where we have someone say customer details, the attributes would be those facts recorded about the entity. Hope that's clear. So here we have an example. We have the customer and then the customer email, the customer ID, things like that. Right. Then we have the relationships. The relationship is simply how business things, how they connect, how they relate, the relationship between the, entities within the business connect. And for example, here we have customer places an order. So we have an entity in this business as customer, we have an entity as an order. We have attributes, which is a fact about either of these entities. So an attribute would be a customer email. An order would be an order number. Oh, I love that, Adenike. Anatomy of a useful model. You should see what Adenike has in the group chat. Exactly. That makes it extremely easy. I love that. Those help me pass exams. It's very easy she put AirCob, and that stands for entity, attribute, relationships, cardinality, optionality, business rule. Remember this because I'm going to ask questions at the end. All right. So I was at relationships and I hope that's clear. So we have two entities. We have customer, we have order. The relationship between them is that a customer would place an order, right? And then we have the cardinality. Cardinality refers to how many instances it can participate, how many instances. For instance, a customer can place multiple orders. A patient can have multiple hospital appointments. They might want to check out their blood sugar levels. At the same time, they might want a scan, they might want an MRI. A patient, being the entity, can have multiple instances of an appointment. just like one customer here in this example can have many orders. That's what cardinality refers to in simple terms. Now we have optionality. Optionality is almost, what it means is whether participation is required. For example, an order must have a customer. And then we have the business rule. Business rule is a whole, is a whole aspect on its own, but here in this context, it's a constraint that must be true. So, for instance, an order must contain at least one product, right? I hope that is clear. So that's basically the anatomy of what a data model looks like. Entity, attributes, relationships, cardinality, optionality, business rules. So we're going to move on. Right, so now we have types of data models, right? What we looked at before, so you don't get it mixed up, was the anatomy, was the core components of a data model. Now, this is looking at the types of data models that exist, right? And I would have loved to ask us this, but it's already on the screen, right? So we have these three primary types of data models, starting with the conceptual model, the logical model, and the physical model, right? So the conceptual model is a high-level business concept. It's a high-level view of the data within the business, right? While a logical model is more detailed. We'll still go into further details, but this is just looking at three of them at a go. So the logical model is detailed. It contains the entity, the attributes, the relationships we just looked at, the rules. This gives you a picture. I'm sure, based on the last slide, you should have a picture of what a logical model will look like. It contains those details, those attributes, relationships, rules, things like that. While the physical one is a lot more detailed and technical on the how and the structure. It has the tables, the columns, indexes, the storage implementation, and as we can see, it's often led by maybe the data architect, depending on whoever it is in your industry. But in mine, I'll say the data architect, right, or developer. The conceptual model is often being led. Earlier I had mentioned how the business analyst is primarily concerned with the what aspect. So what data does the business need? And that's what the conceptual type of data model primarily focuses on, right? While the logical model, it looks at, it goes down a level of detail, but the physical really focuses on the how, and that is like out of scope for what a business analyst typically would do. I know that there's some organizations that make you do everything, which I don't think is possible, but for the physical, it's more, developer led, right? But for the logical, for instance, in some industries, you have BAs, you have BAs building the data models and doing all of that. And in some maybe large organizations, you could have the data analysts in charge of that as well. Okay, so we'll go into more details. Does anybody have any, before I go on, just on the last two slides, is it clear what the core components are and what the type of data models are? Do we understand cardinality? Do we understand optionality? Is that, please, you can thumbs up, or if you want me to summarize any part of this anatomy, you can let me know, or we can reserve that for after we've gone through the presentation. waiting to see if anyone. Okay. So please thumbs up just to show that you're still here, you're still with me, you're still listening. Thank you, Layo. Thank you, Daycare. Okay, great. We're still here. All right. So we've just concluded the core competencies, or the core components rather. The anatomy is what I'm referring to as the core components, and the types of data models. So now we're looking at, I've said the physical is, not BA-led, ideally should not be BA-led. So we're looking at focusing on conceptual and the logical model. So conceptual model, I would say works best for workshops, and it uses business languages, and it shows major entities and relationships within the organization. So for example, we had customer. Thank you so much, Alberto. So we had an example that we looked at. So we were looking at the hospital, for instance. We're also saying customers and orders, right? So a conceptual model will just show the entities and relationships, while the logical model will go down to that level of detail and show the attributes, the rules, cardinality, optionality, things like that, right? While the conceptual model is that, for that high level understanding. And it's really useful in workshops where you can easily get validation from all the stakeholders and have an agreed and shared understanding on the relationships between the major entities and the flow of the data sometimes. Okay. So this is just a simple example, right? I've said here that the focus is the shared business language, not the database detail. And the conceptual model shows the main business concepts and how they relate. We've said that. So this is an example. You can see the customer places an order contains product. A sales channel receives an order is, paid by a payment. Simple, simple like that, very high level, very clear. If you remember, the things that we said makes a good data model, it needs to be clear, it needs to be, in a language that the business understands, it needs to be validated by the stakeholders, right? Okay. So there we have an example of a conceptual model. And then going into a logical model example, this now is a little bit more detailed, right? You can see that you can see the entities. Can someone, I'm sure we know, but what are we seeing? What are the entities in this image that you're looking at? Just put it in the chat. What are the entities you're seeing in this image? Just itemize what you can see that are entities on this slide in the chat. Excuse me.
Hello, can I speak about the numbers of entity I'm seeing?
Yes. Yes.
I'm seeing 5 entities: customer entity, product entity, other entity, payment entity, and other line entity.
Thank you so much, Yakini. I appreciate that. Yes. Thank you, everyone in the chat. So we have Yakini. He said he's seeing 5 entities. So we have the customer, the order line, product, the payment. We also have, yes, correct money, correct Ifeanyiwa, correct, right. So I'm glad that we've said that. Thank you for all your responses. It shows that we clearly understand what we're talking about. So those are the entities, and then we have the attributes underneath them. We have the customer. So attributes are the details about the entity. So we have the full name, the email, the phone. Under the customer, under the order, we have the order date, the status, and other things. We also have relationships. Can we see that the relationship we have one to many, zero to many? So a customer can have zero to many orders. An order can have, one to many order lines. A product as well. We have those relationships. So in summary, I'll explain again. So the conceptual model, let me just go back a slide, is also called a computer independent model. And why do we say it's called a computer independent model? This is because it focuses on, what the model is describing, what the information requirements are. It just identifies that concept within the business and their relationships. Okay, it's supposed to, when you're writing a requirement and they ask you to ensure that your requirements should be solution agnostic. That is how this is a computer independent model. You're just writing and describing the information requirements for the business. As you can see here, there's no system reference, there's no database reference, right? So conceptual model can also be called computer independent model. While the logical model, which is the next one we just looked at, it's where we're starting to think about the design of the database, right? That will be needed. It's where we're starting to think about, what the database needs to implement, or there should be enough of the design for the implementation of a database. So there needs to be this understanding of what the relationships, what the cardinalities are, what the rules, what the business rules are in order for the business to work, right? And we talked about how a physical model is an interpretation of it's out of a business analysis remit, but it's an interpretation of the logical model. It's more detailed. It's the final how the model is, put together. It's the final database, the database schema of how it is. But this is for business analysts. We're business analysts here, so our focus here is primarily the conceptual and logical models. We have some data modeling techniques, such as we have entity relationship diagrams, we have class diagrams, we have data flow diagrams, data dictionaries, and so on, right? Okay, so in modeling the data within an organization, within a business, within an IT system, we have some traps that come up. As business analysts, we know that there are lots of traps that tend to come up when we're doing our work. And these traps come up often. Starting physical too soon, it turns a BA conversation into a database conversation before even the business meaning is stable. You need to have that shared understanding of what the business meaning is, what the entities are. Sometimes it's always helpful to start from a top-down approach. It depends. You can actually take a top-down approach. You can take a bottom-up approach. But you need to first understand. You have no business going physical without understanding the data that you're working with first, right? Now, modeling everything, it creates noise. it just creates noise. You need to, when you're starting a project, as with anything, what's in scope of my project? What's out of scope here? What areas are we looking at? What arms of the business are we focusing on? If you're on a project where you're supposed to model the data, identify the data for the organization, for instance, and maybe some foundation work that will fit into some other maybe data governance work, but you need to do that foundation work of identifying the data and drawing the data model. You need to ask questions as a business analyst, what is in scope? What are we focusing on? What are we starting with? What areas that you don't just go modeling everything, because then it can get complicated fast, right? Also, ignoring cardinality hides business rules. You cannot ignore the instances of how things are supposed to occur. The whole point of this is to bring clarity where there's ambiguity. We need to understand what the business rules are. So you need to understand that a patient, can have multiple appointments. If in your hospital, in your GP, a patient is not allowed to have more than 2 appointments, that can be modeled. You need to show the instances. Is it 1-to? Is it, 1-to-many? Is it 0-to-many? Is it 1-to-1? You need to ensure that cardinality is not ignored, because then you're hiding your business rules. You need to avoid duplicating data. And most importantly, I think we've already talked quite a bit on stakeholder validation. You need stakeholder validation, right? These are common traps not to ignore when you're modeling your business. So, moving on to the next. Yeah, great. Now, in these in this discussion, there's a specific naming convention that we've been using to describe entity types and things like that. Can someone tell me what it is? What's that specific naming convention that we've been using in this discussion? What type of, it's not a trick question, it's just a promise, these like money, you've written order line, product payment. Yekini, you talked about the 5 that you could see the other time. You've talked about customer order. What is this naming convention? What do we think it is? Anybody?
Yes, I didn't get the question.
Okay, thank you. I would explain. Honestly, you'd be surprised at how simple it is. There's a specific naming convention. There's a way that we've been naming the entities, and the attributes, right? There's a way we've been naming the entities. What are they? What types, when you say something is an animal or a place or a thing, that's a clue there. When you say something is an animal, place, or a thing.
Now,
Thank you very much. That is it. It's a singular business noun. So the convention we want is always singular nouns written in business language with consistent naming across the model, right? It's always a singular noun written in the business language, validated with the stakeholders, consistent across the model. Thank you. Thank you. So, to further explain, in naming your entity types right, like we've said, you should use a singular noun. So we have, in a few slides back, we talked about the types or the different types of models that can be drawn. or the different techniques. And we talked about entity relationship modeling. We talked about the class diagram. So I'm not sure we have the time to go into that level of detail, but in the entity relationship diagram, that's where we have, the entity types. And in class diagrams, we have object classes. In case you're wondering what, the object classes mean, but we're focusing on using the example that we've been using, which is the entity type. So using singular nouns, we use business language, like we've said, avoid unexplained abbreviations. That's always such a huge problem. In different arms of the business, the same abbreviation could mean multiple things. As much as possible, try to avoid it. Avoid saying CUST, TBAL, I try to avoid it and just ensure that you keep the naming consistent, right? We also have, the relationships and associations. I think we've, covered that, or cardinality and optionality. We talked about that as well. But let me talk a bit about, the relationship and association. So the business concepts that are represented by the entity types. There are associations between entity types, and that's some of the things we looked at. You might consider these associations as being, a reflection of the business rules or the conditions or the constraints. But it's these associations between the entity types that we need to discover during the development of the model, right? It's these associations that allow us to model the business and its rules via that underlying information that the business requires, right? So we need to have that picture to reflect those associations, and we need to recognize the relationships that exist. For instance, we could have, did somebody say something about property? Okay, no. But for instance, we could have property, we could have a rental agreement. Each property may be rented through one or more rental agreements. For instance, we have a customer could place multiple orders. We have, different things like that. So in an entity relationship model, an association between two entity types is called a relationship, right? So we looked at that already. Cardinality and optionality, I think I explained it a lot, but I'll just repeat that, there could be one-to-one, there could be one-to-many, there could be many-to-many. Optionality helps us, it reveals the rules. Business rules really hide in this area. Can a customer exist in the system without an order? That needs to be, taken into consideration. Can an order exist without a customer? Can one payment settle multiple invoices in your organization? What is that rule for that system? These are the type of BA questions. These are the type of questions you'd ask to uncover that relationship, and then, uncover the cardinality for the data model in building the data model. So must this relationship exist? Can this entity stand alone? What happens before, during, and after the relationship? So an approach to drawing your diagram is, number one, you have to understand the business. You need to know what the business is about. You cannot, go in blind. You need to understand, have that knowledge on the core areas, the core business areas of the business. Take some time. Honestly, as a business analyst, it depends on how we're all working. Some of us work in an organization and we're on a project for, years. Some of us work on short-term projects, or some of us work as consultants to other departments within the organization, or work as consultants for completely new organizations. So of course, you need some time to understand the business. Don't ever make any assumptions. Ensure that you understand the business and you're asking the right questions, right? Once you've done that, identify the entities like we identified today, identify the attributes, identify the relationships, right? Entities, attributes, relationship, customer, order, customer can place many orders. Define the cardinality. So customer may place an order. Cardinality is customer, can place many orders, right? And validate it. Remember, always validate it and simplify it. The easier to understand, the less mistakes, you're likely to have. So some of the tools that you could use to understand or to make your data models or to draw your data models, you have your Miro board, Lucidchart, Visio. You could use any of these. I use Visio primarily in my organization, Lucid as well. I used it in my previous organization and we're using now Miro boards. Very, very useful for workshops. Love them. We also have Lucid. In Lucidchart as well, you have Lucid Spark, which really, really is like a Miro board, but it's really useful, interactive. It has some really nice AI collaborative aspects to it now that really help you get your workshops moving, categorizing things really quickly for you. So you can use these tools to help you facilitate those sessions that will help you get the details you need for your data model. We're not done. I know we're seeing the summary page, but there's still a few slides to go. So what we've covered so far, we've covered the language, we've covered the notation, and we've said models simplify reality. Data is a business fact. Data models represent data and relationships. Entity relationship diagrams and class diagrams use different notations. I didn't go into this in detail, but we talked about entity relationship diagrams and entity types while when I mentioned that class diagrams will have the object classes. I'm not sure we have time to go into that today, but entities and attributes describe business information. Relationships, cardinality, and optionality reveal the rules. The naming matters. Ensure you're using singular nouns. And again, validation keeps the model business owned, right? So we have some questions here. And I think at this point anybody that knows the answer, you can unmute your mic. This is what we've just done. Which model is usually best for early stakeholder alignment? Can anybody tell me their answer and why they think that's the answer? Which of these models? A, we have a physical model. B, we have a conceptual model. C, we have a database index. D, we have an SQL script. Which of these do you think is best for early stakeholder alignment? Okay, great. I think someone is unmuting.
Conceptual model, I think.
Thank you. Thank you.
Conceptual model.
Conceptual model. Thank you, Adebisi. Thank you, Yekini. Does anybody want to try why a conceptual model?
Because sorry.
Go ahead.
I'm happy for you to go first. Sorry. Thank you.
Okay. I think conceptual model is best because it's straightforward and easy to than the logical.
Than any other thing. Thank you. Thank you, Yekini. Yes, the conceptual model, it gives that high-level view. It shows the entities, it shows the relationships, which is what you need to know, to get I'll say a high-level view, a straw man, an understanding of what the business, data model is about. Definitely not a physical model. We've said that that's technically not a business analyst's forte, definitely not a database index, and well, definitely not an SQL script for me. So question 2, in an entity relationship diagram, what does an attribute describe?
An attribute describes the qualities of an entity.
Thank you. Thank you.
B.
If,
Try
if
to
any,
fact about that.
thank you, Feiwa. Thank
B.
you.
A fact about that.
An entity. Thank you, Feiwa. Thank you, Yakini. Thank you, Muni. B. That's correct. It's not a business
The
process.
answer is B.
Yes. Thank you very much. Okay, another one. So, in this scenario, a customer may place many orders, but an order must belong to only one customer. What is being described here?
Cardinality and optionality.
Cardinality
A.
and option.
Thank you. That's correct. Thank you,
A.
everyone.
Cardinality and
Optionality. Thank you, Yakini. Thank you, Bisi. Thank you, Feiwa. Thank you, Lola, in the chat. A. That's correct. Cardinality and optionality. And yeah, this is a cheat question. Which naming style is usually preferred for entity types? I've already asked this before.
Business now.
Yeah, singular business now. Thank you very much. Thank you. So yes, that was correct. Conceptual model, cardinality and optionality, a fact about an entity, single business now. So key takeaways, we have good systems depend on good data structure, and data modeling, it bridges business and technology. Data modeling is a core BA technique. It represents the business rules. Conceptual models support communication. I think it was Yakini and Adebisi that answered that, preferably you would use a conceptual model to get initial stakeholder alignment, right? To ensure that there's a shared understanding. You have a logical model, it supports analysis and design, more looking at, getting down a step from the what to the how and looking at the relationships, the attributes, the optionality, cardinality, and all of that. And then we have data modeling also improves shared understanding. That brings us to the end of the session. Thank you all for listening, and thank you, IIBA, for the opportunity to share my knowledge and add my own little value to our study group. Right. Thank you, Alberto.
Thank you so much, Adrian. It's really an insightful section, and I believe everyone really enjoyed your engagements. I believe there are no more questions for Adrian. Are there any questions? Probably clarifications or maybe some knotty areas we still wanted to unknot. All right. So if there are no other questions, uh, I'd like to say thank you once again, Adu, for taking your time to explain data modeling to the whole house. It's been a wonderful section. I equally enjoyed every little bit of it, and thank you to everyone who was able to participate on this program. So we look forward to next week again when we have another technique that we're going to look at. I think that should be business model canvas. It's going to be another interesting technique to look at. All right. So once again, thank you to everyone. Thank you. Adrian.
Everyone.
Look forward, look forward to you uh, be part of another section again. I hope. All right. Okay. Bye for now, everyone. Good night.
Thank you, everyone. Good night.
Good night.